Hey there, welcome to AppSec Pipelines and Clouds. Oh my. I'm going to call out right away when I pitched this title. The person who I pitched it to looked at me like my head was falling off because they didn't understand the oh my, because they've never seen The Wizard of Oz. Oh, how tragic. My name is Steve Jaguar. Let's learn a little bit more about me, shall we? I'm a cloud security advocate for Prisma Cloud by Palo Alto Networks. I've been writing code since the Stone Ages, and I have current specializations in Kubernetes and container security. I have the triple certification from CKD, CK, and CKS. So I spend too much time tinkering with this kind of cloud technology, clearly. I am a avid application security or AppSec enthusiast. I have worked for a lot of different and experimented with a lot of different tooling in this space, and currently focusing very significantly on supply chain security and what can go wrong there. And we're going to come to that when we talk about emerging threats. If you do happen to enjoy LinkedIn, that is blatantly my QR code right there. So if you're watching this now, in the future, whenever it might be, we can be friends. Isn't that nice? You know, a big community is a better community. Speaking of community, I am the co-organizer of the DevSecOps London Gathering. If you find yourself in London, England, which is where I live in spite of my accent, it's huge. Look it up on Meetup. Come join us. We are there once a month. And I also do a lot of things in the Interbond info web, talking about cloud native security on YouTube and Twitch. So do check me out. I have a very unique last name and am dangerously easy to locate. Let's get into it. We're talking about cloud threats. We're talking about the landscape. We're talking about emerging problems. Let's talk about complexity to start, because that's really the core problem we have. And a lot of these stats, just fair warning, a lot of these numbers, these top fives, they come from a report. We do numerous reports every year. One of them is the state of cloud native security. There's a new one coming out, I think somewhere around June, July this year. Last year we did it. Some interesting bits of information that I thought I would share with you before talking about threats and maybe dropping a little bit of an advice bomb on you. And that being, it's still difficult. Hey, it turns out. Now, I don't necessarily agree. Let's comment. These are the express opinions and ratings of our surveyed talent, let's say. 2,500 respondents, a vast number of organizations that came back to us and told us this is what they think are the challenges. Do I think they're the challenges? Well, wouldn't it be interesting if I challenged their challenges, which I just may. The number one, of course, being technical complexity. I think that was a bit of a softball to start, isn't it? We know that we used to write code. I used to write code. Let's be blunt. I used to write gigantic applications in C and C++, that were multi-threaded, and they would control aviation systems, and they would run on giant servers. Now, the simplicity of it was that it was one big application, and it ran on one big computer, and it was controlling lots of big things. The complexity was that big code bases tend to get a bit spaghettified, and they could be dangerous. Then we learned to deal with that. Nowadays, you're running for the cloud. Well, you probably have a team of 1,000 developers, all broken into two pizza teams of maybe 10 people, creating their little piece of the puzzle. And they've got published APIs, and those APIs are communicating with other APIs in vast Kubernetes clusters and all containerized. Then you've got to push that into the cloud. Well, how do you provision the cloud? Maybe you click ops it. Maybe you're using infrastructure as code, which personally I think is the best way to do things. You get your Terraform or your CloudFormation or your ARM, and you're making it so that you can reproduce your results. And then you've got to make sure that it's actually secure. So you've got VPCs, networks, IAM, you've got identity management. It is complex. With that complexity comes number two, a lack of talent or consulting services. Heck yeah, we're moving too fast, but we want to be first to market. So we're going as fast as we can. And we're introducing some risk along the way. What risk? Number three, we don't understand the security requirements of doing what we're doing. And the way the market has developed in terms of how we secure things over the past 8 years is interesting. We're always just behind the curve, trying to make sure we secure what you've already done. Now, this could be container security. Sure. 2015, how many container security startups popped out of nowhere, competing with one another to show you we can scan this image? We can scan the container at runtime. We can scan your registry. Findings, findings, findings. It was good and kind of bad. We're in the cloud. 2018, 2019, suddenly Gartner comes out with CSPM, Cloud Security Posture Management. Is my cloud even configured correctly? How many S3 buckets are out there unencrypted and open to the public with all my data in it? It was a problem, but we're getting better at it. But now I've got two security solutions. You can see where this is going. We've been doing a lot of point solutions to try and solve the problems as we discovered them. What if I have, do I even have visibility if I'm multi-cloud? Do I have a separate set of security solutions for my AWS as I do for my Azure, as I do for my GCP? And amongst all of this, of course, the necessary evil of all things that we do, no matter what industry it seems we're in, meeting our compliance requirements. Yuck. You got to do it though. What's interesting about compliance requirements, be it PCI or HIPAA or whatever world you're in, they exist not because they want to exist. They exist because we did a bad job. It's our fault. If we were doing such a great job, they wouldn't even need to be enforcing some sort of minimum security compliance requirement on us. As long as we continue to make these problems, more things will happen. For example, a requirement for software bills and materials. Ugh. It's getting difficult, and it's not going to stop. Let's move swiftly onwards. Now, let's take a look at, before we look at this 5, let's take a look at this 90%. 90% of organizations reported that they cannot detect, contain, and resolve cyber threats within an hour. Is an hour good? It's actually not bad, but this was the number we were looking at in terms of meeting certain standards. And I can see why. Because if you, depending on what your tooling is doing, even if you've got the greatest observability, maybe if you've tackled that and you can see everything, can you act? Can you actually create a remediation plan that can extend all the way back to the developers who maybe created the problem in the first place within an hour? Are you using something that is actually giving you real-time access? Or are you scanning your cloud environments with your applications maybe once every 24 hours? In which case, yeah, your worst case scenario could be 23 hours and 59 minutes. There's certain platforms that just aren't really prepared for this kind of response time. Now, going over the top 5 in terms of the incidents themselves that are considered to be to blame for the sort of threats that we're concerned about resolving in an hour, the number 1, which was interesting, is risk introduced early in the application development. Now, I'm going to go out there and suggest that this could be the vulnerabilities introduced through our own code that I personally write. I don't follow best practices. Maybe I'm not using a language or a framework that mitigates certain risks, like cross-site request forgery or something like. Maybe I'm doing something that I'm creating a 0-day, a fantastic new poor design that means it's not going to go well and no one's predicted it yet. A great example of that would be the log4j misstep, when it had been there for ages and nobody considered that that particular attack vector could be used to exploit that particular vulnerability in our logging. It's new and that happens, but it's actually pretty rare. It makes headlines. Log4j and the log4shell attack vector was huge, but it doesn't actually happen that often. So it's interesting that people probably see this order of operations and think, I need a static analysis tool for my code. That's number 1, but it's not the most common problem. Workload images with vulnerabilities or malware. Yeah, that's definitely a problem. I did mention earlier, back in 2015, all these different tools popped up showing us how to make sure we're analyzing images. We're looking for malware. We're making sure there's nothing anomalous running in there like crypto miners. We've got a pretty good solid background in that after almost 10 years of securing the move to containerization. Doesn't mean it's not number 2 on people's minds. It's interesting. I saw a presentation by a comedian called Dara O'Brien. He's an Irish comedian. Look him up. If you can spell Dara O'Brien, it's an Irish spelling, probably not based on what I just said. And he said, the fear of zombies is very high, but the actual risk of zombies, not so much. It's interesting how people perceive threats or have fears and whether they actually manifest as real, tangible risk. Now, we're at number 3, and I actually think this is potentially more something that should be up at number one. Vulnerable web applications, known vulnerabilities that we have accidentally not upgraded or have arisen in our runtime. And of course, the possibly insecure APIs that we leave in the hands of our developers that may or may not be treating our input parameters in a secure way. This is legitimate, and there, of course, are new exciting startups in this space looking to make sure that our APIs and vulnerable web applications have some element of security around them and are looking for anomalous behavior. Number four, the classic unrestricted network access between workloads. This is if I can get into something vulnerable, either from the outside or even as a malicious insider that someone has provisioned with a bit of a weakness. A good example was a few years back, there was a way to send a manifest into a particular type of load balancer that would allow for remote code execution. And you could get access to a container that actually had pretty much administrator access within a Kubernetes cluster. Now, that container wasn't particularly powerful, but where could I go from there was the real question. And were the correct network policies both within the Kubernetes cluster set up correctly and for the underlying hypervisor that was running Kubernetes? Were those network policies configured correctly? It is amazing how often we find that the egg analogy, the hard outer, and once we're inside, we consider ourselves to be in a container or in a VM that no one should ever be there. So we've got access to maybe too much metadata or too many secrets within there that is going to allow for someone to move laterally and potentially find our keys to the kingdom. This is a real legitimate threat. I agree with that one. Finally, downtime or unrestricted access due to misconfiguration. Misconfigurations generally I see as the biggest threat. I would almost reverse this entire list if it were me, but it is huge. It's so easy to misconfigure something. Back in the good old days of the cloud, when there was two services, which was EC2 and S3, not a problem. Just a virtual version of what we had before. Put your data and your stuff here, run everything on the virtual server, off we go. Lift and shift was a dawdle. Now, just AWS alone has over 250 services that you need to know how to set up correctly and to make them communicate with one another in a secure method that represents least privilege. Good luck. That is difficult, even when using infrastructure as code. What are the challenges to providing comprehensive security across all of these problems that I've just been evangelizing about? Well, one of the biggest ones is that holistic nature of a solution. I keep talking about these startups were created, and this year these startups were created, and then this year these startups were created. Well, what's the vision I have across all of those tools? Is there one way to see all the different findings and results and potential risks across them all? More often not. Additionally, because the security solution providers in this space have been isolated, so are my teams quite often. So I have one team maybe running my application security solutions, another team running my cloud security solutions, maybe a platform team who's got it all together, who's looking at securing my pipeline. Maybe, if I'm lucky, I'm only talking to 3 teams. Classic number 2, making sure that my developers and my operations teams, let's call them DevOps, are actually implementing security or best practices as code is being developed, as infrastructure as code is being developed. It's all part of the application. Are they doing the right things? Is it my fault if they aren't? Well, it's a shared responsibility model, let's call it. It's an organizational culture that means developers will get involved, but also sometimes as vendors, they don't do a good job. I've been involved in going way back. There used to be a culture of sell a big, awesome security tool to the security people with no real consideration as to whether the developer experience was palatable at all. And these things just don't roll out. They become shelfware. Since then, we're getting quite good at that. And I will talk a little bit more about that as we move on. Number 3, training all staff to use security tools. I think this is valid to think this way, but I would add to that and say security tools should be easier to use because in the past, they just haven't been. I also think that security or all tools should be more like when you get a PlayStation game where it kind of teaches you how to play. You don't get a manual out and learn how to play the game. It's showing you how to do what you need to do as you go. And then suddenly, after 24 hours of binge playing, you're doing feats of incredible acrobatics in this game that you never thought possible when you first started. You've got all the button combinations all worked out. This is how security should be. We should be integrating into the existing ecosystem in a seamless way. So when new security things arise, well, we just learned a small little piece there, but that's helped me. Oh, I learned another small little piece there. This is the way things should be. And again, I'm optimistic we are moving in that direction. A huge one, a lack of visibility into vulnerabilities. And now this is across all my clouds. Lots of different tools reporting lots of different alerts on lots of different vulnerabilities and misconfigurations, potentially across a lot of clouds. This is a legitimate problem. The reality is that vulnerabilities and misconfigurations don't represent risk unless they do. What is the context? Is it reachable? Is it actually one vulnerability in many locations? I need to get absolute certainty that what I'm fixing is worthy of being fixed. Otherwise, I have no time to fix all of it. It's impossible. Finally, finding the correct tools needed to address my security needs. I believe this completely. Everybody is sending the same messaging. Everybody's saying the same thing, and everybody's telling you to go buy this stuff. And it leads to a huge problem. And this is it. We surveyed and found that most organizations are using over 30 security tools. This kind of blew our minds. 6 to 10 tools dedicated to cloud security. 6 to 10. Like, what? That's siloing. That is confusing. No wonder that they are struggling to identify what security tools are required for certain objectives, and that 76% feel like they're sometimes less secure because the tools themselves have created blind spots they don't understand. Imagine if you've got 6 to 10 security tools and you create a big Venn diagram and you overlap what parts of the organization that you think they cover, and there's these like white spaces in there that just simply are uncovered. How do you even know that? It's really, really difficult, and it's become a problem. And it's nobody's fault, really, but it's the way the cloud native world has progressed. Because as security risks are identified, we've been coming up with spot tools to the point where you got to get them. But now that we're looking at it from a holistic perspective, we realize, oh, we should actually be combining these things together. And that is what we're going to come to. Now I'm going to take a little aside, just to kind of wake everybody up. But last reInvent 2023, if you're watching this in the future, in October, Werner Vogel gave a very good CTO presentation where he presented a website. You can look it up, called The Frugal Architect. Simple laws for building cost-aware, sustainable, and modern architectures. Very nice. Little artist rendering of him right there, looking at his own book. It was really good. Now, regardless, you should go take a look at it because cost is a risk as well. But there was rule number 4 that struck me as this is good for more than just cost. Unobserved systems lead to unknown costs. And it said, without careful observation and measurement, the true costs of operating a system remain invisible. This already sounds threatening. Well, what if I change the word costs to risks? The true risks of operating a system remain invisible without careful observation. I agree with it. And it is something that was one of the statistics I just presented. He is correct. I can't secure what I can't see. And if I buy more tools and I create more blind spots, that is not necessarily solving my problem. It's a solution that creates a new problem. And this is something we need to work on. Now, coming out of that little break, I'm going to talk to you about emerging threats, which I think is something that has been hiding in the shadows for quite some time. And as we've been improving the way that we implement security strategies in cloud native, image scanning being a great example of this, where I think we're really quite good, the attackers have been looking for new innovative ways of doing things. And that is where I'm going to redefine the application. What is the application when we say application security, or when we say a cloud native application? What is it? Now, in the past, we all agreed it's the code I write. I used to write code. It was definitely part of the application, no doubt. Then we got really into open source, accelerating our work and upwards. Most applications in the cloud native space, many surveys say upwards of 80% of our code is imported code from open source dependencies. So our development team is actually huge. We just don't know who half of them are. It already says risk right on it. So that is something that we're quite good at. Maybe we get a software composition analysis tool to take a look at that so that we feel better about it. Cool. The cloud it runs in. Now, this could be controversial. There are InfoSec teams out there that say we are securing the cloud, don't care about the application. And there are application security teams who are saying, yep, we're getting an application, we're going to throw that into the cloud. Now, the problem we have here is that the people who are provisioning the cloud using, let's say, infrastructure as code like Terraform, well, that's an application. And that application, there are dependencies and there are aspects of coupling between the application because it depends on the cloud being there and the storage being there. All the aspects of where it's running, there is a very, very, very tight relationship between the cloud itself and the application. So we're starting to think, well, wait, that's actually part of the application and it's code and it's in Git. Let's just treat it as such. Now, finally, the pipeline that builds it. Now, maybe you might think this is a stretch, but the pipeline is something that is critical because it builds / transforms the code that goes into it into its release state, which means it is like a automated piece of our development team. It is doing a lot of dependency checking. It's bringing things in. It's running our security solutions. It's trusting our security solutions. And it's ultimately creating the final product and deploying it to our destination. There's a lot of trust there to not ensure that this is definitely a potential security risk and that we should be looking at it as a first-class security citizen. Why? Well, let's look at the breaches for the past few years. They're pretty much all pipeline security problems. We have dependency issues. You look at CodeCov and SolarWinds. CodeCov and SolarWinds are absolutely supply chain pipeline issues. In fact, these were so prominent that it prompted some individuals to create an OWASP top 10 just for CI/CD security risks. And if you look at SolarWinds and CodeCov, yeah, number 9, improper artifact integrity validation was a part of that. Dependency chain abuse was a part of that. This top 10 does represent reality and something that we need to be treating with ultimate seriousness. So this really is our emerging threat. And with all of the dependencies upstream on open source projects or even closed source projects in the example of SolarWinds, we have to be extra diligent and extra vigilant in making sure that we're paying attention to this. So this is the emerging threat within application security within our cloud landscape. And yet, if I look at all of these, the code I write is a SAS tool, static analysis. The dependencies is a software composition analysis tool. The cloud it runs in is probably Cloud Security Posture Management or CWPP, Cloud Workload Protection Platform, looking at our runtime, amongst other runtime issues. You could have a web application and API security tool or a WAS or a WAF, depending on what you're doing. You need something for your CI/CD security. We don't have a cool acronym for that one yet, but I'm already at 6 tools. No wonder everybody has 6 to 10 different cloud security tools. I can name 6 right away. And that's a problem because when you divide your tools, you get kind of this reverse Conway's law scenario where the organizations have kind of siloed security teams based on tool expertise and the technological geographies associated with them. And that's not ideal. We need to bring things together. So what's our path forward? Consolidating our tools and therefore consolidating our silos. Let's all start speaking the same language. Let's see if we can get something to one tool to rule them all. Well, that would be wonderful, wouldn't it? It's not easy to find something like that, but I think it's always a good idea to consider tool consolidation whenever possible. Great example would be software composition analysis. So finding known vulnerabilities and dependencies and in my cloud, combine the application ones with SAST. When static analysis runs on your code, most of them create something called an abstract syntax tree, which shows you all the paths that are being traversed during test. If I can do that, if I have that information and I combine it with software composition analysis, I might be able to see which of my vast list of dependency vulnerabilities are actually being executed or actually being run. Wouldn't that be nice? Now, let's take the same example, put it into runtime. If I could look at my CSPM results or even my CWPP observability, and I know where my vulnerabilities are, for example, in a container, can I see that there's even a route through the cloud to it? Can I see that it's not already being, the risk is already being mitigated by some other measure? This is important. The combination of tools is huge, not just for relieving alert fatigue and tool fatigue. It's actually critical for removing those weird gaps that the disparate tools have created and rising to the top something that represents real risk for the business. I think this is the number one direction we need to go. The results are taking examples of maybe 5,000 different vulnerabilities and misconfigurations and distilling them down through a series of filters and elements of reachability provided by the combining of all the data with all these tools so that I'm only really acting on 15 things. You know what? I can deal with that. I can create workflows to send that information to the right people, be it through a ticketing system or perhaps through auto-generated pull requests within Git to explain all of this information in a way that is actually actionable. How rare would that be? Another example I'd like to see, I think, in a good tool is just using the concept of attack paths. Now you can see the diagram here. I can see that there's internet exposure coming in, say, through a load balancer, and then somewhere on a virtual machine, I have both a misconfiguration that might get access to personally identifiable information, plus a critical vulnerability that I could fix to mitigate this risk. I have got location, and I can see that the path is real. Well, the ideal scenario here is how can I achieve this? It's not through one thing. This looks like it's combining a web application firewall. It's combining with CSPM. It's combining with an SCA tool. It's combining with an infrastructure as code monitoring tool. And it can also do something like DSPM, data security posture management, to know that the data that's connected to it actually contains something I care about. This is a great example of mushing together some of our security silos and then creating some actions based on fixing it now in the cloud. So leveraging a traditional CSPM remediation method, but also fixing in code and sending a pull request back to the original author. Wouldn't that be amazing? And that's the way forward. I mean, we can only achieve this through platformization of all of the tools that we already have in our locker. Now, the final nirvana, which would be great to achieve, is if our solution extends all the way back to the original developer so that we can prevent. Modern solutions already do this. And I think if you're looking for tooling, you should always check to see, do you integrate with my developers' IDEs? Like VS Code or the series of JetBrains ones are the most common. As they create Terraform or as they create personal code, be that in, say, for example, Java or JavaScript, can it tell them what they're doing wrong in an educational way as it's happening? And the answer is yes. If you look carefully, you can find solutions that do this and become developer friendly. Why send them alerts or tickets that they're never going to fix if you could do it right there and educate them in the process? Now, I would be remiss if I didn't say this example on the screen is powered by an open source tool called Chekhov that I work on. So yay, I just plugged myself. Hurrah. You can look it up, chekhov.io if you want to learn more. This is the final step. Now, if we can do this, we can combine everything together into one big platform, and we can communicate in the language of DevOps and developers so that our shift left strategy is great. We know what's going to happen. Things are going to get real quiet in runtime. Now, I found this quote from Robin Williams, or even fools seem smart when they are quiet. Now, that's kind of funny. I like it. But I misread it the first time I saw the screen. And I actually thought, because I had this on the brain, I thought it said tools. Even tools seem smart when they are quiet. And I thought, yes, this applies to our world. Our runtimes are too noisy. There's too much going on. We're focusing on alerts. We're getting findings fatigue. We're getting tools fatigue. If we can combine all of this knowledge at runtime, and push all of the education to the left so developers are doing as much as they can, we're going to have a very quiet runtime. We're only going to be looking at risk. And suddenly we're going to have an incredibly efficient cloud native security strategy, regardless of the new emerging threats. All right. That's the end of my presentation. I hope you enjoyed it. My name is Steve Giguere.